Hello everyone, welcome back to the channel. I'm so glad you are here because today we are diving into something that's both fundamental and exciting for embedded developer, which is writing a GPIO driver for STM32f4 from scratch. So the GPIO, as you know, or general purpose input output, is the backbone of any microcontroller project, whether you are juggling LEDs, reading buttons, or interfacing with sensors. So GPIO pin make it all possible. So in this video we are going to take a hands-on approach, starting from the bare metal configuration to writing usable code in C code for sure that you can build upon in future projects. So if you are new here or just tuning back in after a break, don't forget to subscribe and hit that notification bell. This way you won't miss any update as we explore embedded system development one driver at a time. So alright, grab your STM32 4 ports. And yeah, so during this presentation we have a plan. So we will go through an introduction, then we have an overview, and we will start implementation of the GPIO driver in C code, and then finally we try to test this in real board. So as you know, so the GPIO pin are used to interface with external hardware such as sensors, LEDs, and switch. And there are two types. So there is input pins and output pins. So for the input pins, so it's meant to read data from external sources like button press or sensors. Yeah, and for the output pin, it's like sending some signal to control external device like to send some signals to control LEDs or send some PWM signals to control motors and so on. Then, so for this overview, we will go through GPIO driver register. So we will see how to configure pin as input or output, try to read the data from GPIO pins or send some signal like PWM or some data over UART communication. And yeah, so for the GPIO pin modes and configuration, so we will go through all these modes in the datasheet for the STM32, and I will put the link for this document that I will show now. So we have this document, and this is for many microcontrollers. So for STM32F405, 415, and 0715. So for the GPIO, we have some information about the feature that this board can support, or this microcontroller. So it has, for example, 16 input output, and it has many different output states like push pull or open drain, or pull up or down or pull down. And also you can configure the speed of the input output, and also the input state flow chain, pull ups, pull down, or analog. So yeah, so there is many information about the GPIO driver. So for this, because there is too many information, so we will go to GPIO register because we were trying to write a driver from scratch for this GPIO for STM32f4. And then we have a register called GPIO X model. So for this, so because as we mentioned before that there is two type, so GPIO either as input or output mode. So for this we have input. So if, for example, it's like reading some state like button state or something like this, or general purpose output, so to control something, so like LEDs or some motors. Alternate function mode, so this can be used for example, if you want to implement some protocol of some communication protocols like UART, SPI, I2C. So we are gonna use this alternate function mode. And for the analogic mode, it's like, so you are reading some analog signal from sensor directly. So we have to use this analog mode. And for the out typer, GPIO out typer. So for this, if you want to configure, for example, GPIO pin 14 or 13, you have to shift that value to this position. So 26 for the, so for example, you have to shift the value to the position 26 for pin 13, or for example, for pin 3, you have to shift it to bit number 6, and so on. And for the GPIO output type outkeeper, so this is used, for example, it's like the default state for this GPIO. So for example, for the default state is pulled up, or maybe you can put it in open drain. And also for the speed, so you can control the speed of the GPIO pins. So for example, low speed, medium speed, high speed, and very high speed depend on the application. So if there is some application that need uh, high speed for that GPIO, so you can change the speed in this register. And for the pull up, pull down register, so yeah, so it depends whether you want the rest stage of your GPIO to be up, down, or no pull up, no down. So you can control it by yourself. So you can control this register by writing these values to this register. Also, we have input data register. So uh, for example, you are reading some sensor values using some like protocols or some state, for example, of LED, of some inputs, so you can read this register directly. And for the output, if you want to control some outputs, sending some data or controlling some LEDs or motors, so you can write value directly to this register. So I think it's just also so so also this is for set and reset register. So you can, so for setting the value, you have to put value to this from 0 to 14 because it has 31 bit. And if you want to set a value to, for example, to pin number 2, you have to put value 1 to this position. And if you want to reset this pin, you have to shift it to this 18. Then you can reset this pin. So for example, for pin 2, if you want to set the value, you have to write in this position 2. If you want to reset the value, you have to write the value to this position 18. Yeah, so for this configuration lock register, I did use before, but maybe in next videos we will try to use this and to discover together the purpose of these bits or this register. And for alternate function, so for example, if you want to use a specific pin for UART communication or SPI, so you have to use in the motor, you have to put alternate function where this is okay. So you have to put alternate function mode, and for the alternate mode register, you have to select this. So I will show you. I will show you now. So for example, for IF3, so for example, there is from 0 to 15. I will try to look for this. So yeah, so selecting alternate function on STM32f4. So if you want timer 8 till 11, so you have to select IF3. If you want timer 1 or timer 2 on a specific pin, you have to put to that register of iteration function AF1. And for example, if you want to use UART or SPI, for example SPI3, so you have to select AF6, so and so on. So there is a register low and register high, so it depends on the pins number. So this is for pin 0 to 7, and this is from 8 to 15. So if you want to set pin, for example, 13 to SPI mode, so you have to SPI 1, you have to set the register GPIO IF RH to SPR3 to AF6. Yeah. So now we will go to the implementation and try to write the code in C. So I already did this before. I will show you the steps to create the project from scratch and try to write the code by yourself. So this is my, so you can go to project, new macrovision project, and for example we'll put tutorial 01 and the name for the project GPIO Driver. Then save, and here you need to select your port. So in my case I'm using STM32f4 GPIO. Okay, then you have to select the core under same SIS, and also the device you have to select the startup. So only these two files are required. Then you click OK. Then you have to add a main file .c and so on. So I really create the project, so I will try to open this. So we have three files. So we have main.c and GPIO source code and the header. So in the header, so I will share with you all these documents. So for the headers, so you have to use this f&f GPIO just to prevent looping while including the file. So maybe it's included into different files, so we protect or we prevent this by adding this f&f and define and also intf. And then so we have some macros. So we have low value, high, and state enabled for some purpose. So this enumeration I didn't use, but yeah, so I declared. And then we have a GPIO pin number 0. So I create macros for each pin. So pin 15, and for GPIO pin all to select all the pins. Then we have, for example, if you try to set something or modify something, so there is some error codes, true state, false, init state, and this is for, so I create macros for this. So I create this for macros for mode register. So there is input, general purpose output, alternate function, and analog mode. So yeah, input, output, alternate, analog, and this is the value in hex. And also for the register OTPer, there is two states, so pull and open drain. The same thing for the speed, so we have low speed, medium speed, high speed, very high speed. So this is every state or every macros. Yeah, I just use this document to write this header file. Yeah, so this is alternate function as we saw before, and we have, this is for just some some state for initialization of the GPIO driver, and also this is a state, API state. So for example, if some errors occurs while trying to set the mode or set the type, set speed, so we can return if it's if the initialization uh, is passed or failed. And here is the struct. So it has type def of GPIO. So we can use so this you can use to configure any GPIO. So you have to pass only which GPIO you want to, for example, to configure. For example, GPIO G, GPIO P, whatever. And then you can select the pin, mode, of shape, speed, and pull and alternate function based on the header file. And then we have the function. So this is to initialize the struct, and this is to initialize the GPIO struct, and this is to write pin and toggle pin. So we write only two APIs. This is to write, so you can write for example 0 value, or you can 0 mean that's enabled, disabled or enabled, and this is to toggle the pin. So the C code, so we have some local functions. So this is for uh, init the GPIO struct and the state struct, and this is for setting the mode, for setting type, speed, and pull and alternate function. And the parameters the same, the GPIO, and you have to pass also the pin and which mode you want. And this is for the API state. So this is for future uh, benefits. So for the mode I don't use. So we are focusing more on these three parameters. So we have to pass the GPIO and the pin number and the mode, and for the setting type you have to pass the type, speed, pull, and which alternate function you are using. So this we will discard this for the moment. And for GPIO init, so we put the driver state as init, since we are in initialization step, and this is for setting the GPIO mode. So we are getting the which GPIO that we want to configure, and this is the pin number. So everything is stored in this GPIO struct, and this is the mode and the API state. So we don't care about this. So GPIO also it's same parameters, two parameters are same, and this last parameter or the third parameter is regarding the mode, type, speed, pull, alternate function. So it's not something that difficult. And this is that return if an error happens. If nothing, so we can go on. So and this is driver to write the pin. So if the state is 0, because we are passing two values, so if state 0, so we are trying uh, to set the, so if it's 1, so we are trying to set the value base RR to 1. So if it's 0, it means that we are trying to reset, so we are shifting by 16, because as I mentioned before, so we have two registers for setting and resetting. So for example, if you want to set the value, for example, to 0, we have to put 1 in this position. If you want to reset, we have to put or to change the value of this BR. So we have base 0 for pin 0, base 11 for pin 11, and base 15 for pin 15, and the same for this. So for example, for if we want to reset the pin number 0, so we have to modify this bit register, so we have to shift by 16. If we want to reset this value or this pin, for example pin number 1, so we have 1 plus 16, which is 17. The same for this one, so we have to shift by 16, so it's 10 plus 16, it's 26. and so on. So that's why we are shifting the pin number by 16. Then we have toggle pin. So the toggle, it's like we're trying to toggle this register PSRR. And so if it's 1, so we are shifting 1. If it's 0, so we're trying to put 0. And so this is just for some purpose. And we have, this is our main function to configure the register. So we are passing the main parameters, so GPIO, pin, and the mode, and we don't care about this. So we are trying to clear the bits of this pin. So we are trying to clear 2 bits, because so this value 2, which means that, so this is for mode. So for example, for this we have to clear this, so that's why I'm trying to clear this 2 bits. So that's why I'm shifting 2, because 2, it means that, so 2 shifted pin multiply by 2. Then we have to shift, so for example, so this is why we are multiplying by 2, because if we want, so for example, if we want uh, to change the mode for the pin number 4, so we have to shift 4 multiplied by 2, so which is 8. So let's see and check. So 4, so 4 model 3 model 4, so it's 8. That's why we are multiplying 2 to modify the pin or the bits for the register model for pin number 4. So you have to multiply by 2, then shift and put the value of the mode in that register, then return state OK if we execute those action. So the same thing for the type. So we are trying to clear everything, so we are trying to clear all the register and try to shift, so this type, so we are trying to shift also the type to the pin. So since we have only 1 bit per each pin, so it means that you can shift only by the pin number. So if you want to set the type for the pin number 6, you have to shift just by pin number. You don't have to multiply by 2 or something like this. Then so it's typed and shifted by the pin number. And for the speed, the same procedure for motor, because it has 2 bits, so you have to multiply by 2, then shift the mode or the speed that you want to that position. The same thing also for the pull register, so you have to clear the register, then try to shift the value to that position. And since it has 2 bits, so for the pull it has 2 bits per each, yeah, per each pin. So you have to multiply by 2, then shift. The same thing for alternate function. So since we have 2 register, low register and high register, so if the pin is below than 8, so we can use this method. And why we are multiplying by 4, because for each pin it has 4 bits, so that's why. So for pin 0 we have 0 1 2 3, so 4 bits, so you have to multiply by 4, then switch, then shift. And then if the number is above 8, so you have to use the register high. So this is a register low, IFR 0, it means low, and for the high you have to use the second uh, table or second register, so which is high, and then you can use the same calculation. And yeah, it's done. So For the main C, so you have to include these parameters. So it's stdu point dot h and all this library and our library that we created from scratch. And for example, API state. So this is you can just use it because we create a function, and this is we will benefit from it once we are trying to call a different driver to initialize multiple drivers. So we have to maybe sometimes something wrong happens, so we need to figure out in which uh, driver and so on. And so for the main, so we have the API states. This is only for initialization, and also we have to enable the register RCC for that register, because if you didn't, so for example for this we can go to the register RCC log. So APB, so in this register we can find the GPIO APB1 or APB2, so we can find the GPIO driver. So let me check again. So APB1 0 to number 6. HPB1, sorry, HPB1. So yeah, so in this HPB1 you can find all GPIO, and you have to enable that GPIO that you want to use. For example, in our case, so for our case we want to use, so we want to control this LED and this. So there is this, yeah, so this is clear. So there is an LED, so it's PG14. So we want in this tutorial to control this LED. So you have to enable the RCC to this specific GPIO G. So that's why I'm trying to shift one to this position. GPIO G enable the clock. Then we have this while, and before this we have to write a function and to pass the parameters. So we have a structure for GPIO, and we are passing the GPIO to GPIO X, for example, in that structure. So we are trying to control the GPIO G. Number of the pin is 14 for the LED. So for the mode it's output mode, and for the out chip it's push pull. You can put yeah, doesn't matter this. And for the speed, we don't care about the speed, so I put it as a low speed. And for the pull up, so no pull, because I'm trying to control as low or high. And then you can call this function to initialize all these parameters. And the same thing for pin number 13. And then we have this write function, so you can pass to GPIOG, and this is the position of the pin, so pin 14. So you can either pass like this, or you can just put the pin number. So this is, I can show you because sometimes, so I prefer to write it in hex. So it's, sorry, it's 14. So let's try to So there is no error, and I'm connecting now. I'm connecting the my board, and also I will try also to connect a logic analyzer, so you can find a logic analyzer. So I'm using this one, logic analyzer. So currently I'm using this one, so I bought it from AliExpress, so you can use the same. And the software is this one, so it's, you can also find it. It's, I can show you the name. So this is the the software that I'm using now to analyze the signals. So I will put all the links for these tools now. So we have a code, we connect our board, and now we are building, and I will try now to connect the logic analyzer and check for the pin number 14. So I'm connecting now. So I will open this logic analyzer. So I will name this. So I'm connecting on the number GPIO G14. So okay, so as you can see, there is nothing as output. So I will try to flash the software and see if there is something happen. Okay, so there is nothing, and also I'm not seeing the LED is blinking. So the code is trying to write value high, and since we don't have the the, the delay function, so I'm just using this loop to create a delay. Then I'm writing 0 to this pin, so it's like toggling, but I cannot see anything in this GPIO pin, and also the LED doesn't blink. So let's try to debug this. So one issue, I will check the RCC if it's enabled for the GPIO HPB1 enable register. It seems it's not. So this is GPIO, it's not set. Sorry. So it's set to 1. Okay. Now let me check the GPIO itself. So as I can see that the output register is toggling, but no output. And the value is set to 1 for the pin number 14, but so we have, yeah, so we have first issue. So let's try to debug this and see what's the problem. So for the GPIO mode, we have to set it as output. So it means value 01